I have d as the parameter for this function, and x is the variable. So what did you get for g of 0? G of 0 is 0. Plug in 0 for x, and 0 cubed is 0, and d times 0 is 0, so g of 0 is 0. No matter what d is, if I set up this thing and move d around, it doesn't matter where I put d, it's always going to pass through that point at 0, 0, regardless of where d goes. What about g prime of 0? You have that it is negative d. What is g double prime of 0? So g double prime of x is, well, now I'm taking the derivative of 3x squared minus d, so it's just 6x. So g double prime of 0 is equal to 6 times 0, which is 0. Well, so it's kind of interesting because when the g of 0 is 0, the parameter definitely doesn't affect that. So what that means is if you wanted to fit something to this curve and it did not have g of 0 equals 0, you would be out of luck. Like you can't say I want to have a curve of this x cubed minus dx form that passes through 0, 1, because this always has 0, passes through 0, 0. On the second derivative, it does look like d changes the behavior. Well, it changes the behavior around. That's what we're going to have to investigate. It looks like this is always a place where something happens with concavity, and our goal is to investigate exactly what happens with it at 0, because the second derivative controls concavity. But unlike when you actually plug in the function, that's a static value, whereas when you plug in the derivative, that tells you what's happening on a little motion in a little interval of change. Things are changing a little bit around 0 with the second derivative, and we're going to figure out how. How many critical points do you see here? 2. There are definitely 2 critical points here. That's non-controversial. The question is, does that depend on d at all? And that's something we can try to determine visually, or we can go back to our algebra and look at that. So visually, as we slide through, let's see if the number of critical points changes. Does it look like the number of critical points changes as I slide this? So there are 2 critical points for some of these numbers, and then there reaches a point where there's just 1, and what's happening? Where is that happening? Yeah, so it looks like there are 2 critical points for d larger than 0, but then it also looks like if we slide lower than 0, or at 0 right there, I only see 1 critical point, and then as it becomes negative, I only have 1 critical point. Let's look at it. Let's see what happens here. This is something where it's really helpful to have the derivative at our disposal to investigate more finely. It's almost like a microscope. So y'all told me correctly that if g of x is equal to x cubed minus dx, then g prime of x is equal to 3x squared minus d. And so I want to solve 3x squared minus d equals 0. Technically, I should also look at where 3x squared minus d does not exist, but that doesn't actually come into play because it's a polynomial. So that, in this case, you can ignore that. Let's go through and solve 3x squared minus d. What's the first thing I should do? Now, why might that go from having 2 answers to 1 answer to 0 answers, depending on the value of d? If d is 0, then this becomes plus or minus square root of 0 over 3. So that's just plus or minus square root of 0, which plus or minus 0 is 0. So there's only one solution then. There's one answer if d is equal to 0. Yeah, if d is less than 0, you're looking at plus or minus the square root of a negative number over 3. We cannot take the square root of a negative number in this class. We end up with what are called imaginary numbers. So in this case, we have no solution. Now, if d is less than 0, there are no critical points because there are no solutions to g prime of x equals 0. Here we have one solution to g prime of x equals 0, so 1 critical point. And here we have two actual numbers, we get a square root, we have a positive or negative. So if D is greater than 0, then we have two solutions or two critical points. And this also helps to explain why when D gets larger in my graph, the critical points are spreading out. See how the critical points are getting further and further apart? Because they're at plus or minus square root of D over 3.